Hello friends, today I'm going to start the discussion of NMR spectroscopy. Before getting into the chapter or before getting into the questions which are asked in the previous year, we need to discuss about the basic fundamentals of NMR spectroscopy. Once we are able to understand the fundamentals, it's going to easy to solve some problems as well as we can work out with our writing skills. So without wasting time, let's get into the topic. And before starting the main course of the topic, let's discuss the basic fundamental things. Personally, I feel that we are lagging into those things also. I'm trying to discuss those things. I'm using some slides to save some time. Now, NMR spectroscopy is based on the nuclear motions. So, starting with the basic, if we talk about the electron, electron revolves around the nucleus as well as around its axis. And when they rotate around their axis, either in clockwise direction or in anti-clockwise direction, they generate angular momentum. And the electron and the angular momentum of electron is given by the expression which you can see on the screen. Now, why I'm discussing the electron? इलेक्ट्रॉन को समझकर हमें न्यूक्लियस को समझना है. So it's better to understand the electron initially, then we will discuss about the nucleus. Okay. Now, in this expression, S represents the spin quantum number, and we know that in general, for an anti-clockwise motion, the value of spin quantum number is given by -1/2. Although it is not fixed, you can give plus half or minus half, but I'm just taking. Correct? Now, when rotating body generate angular momentum, its angular momentum depend upon some specific value. In case of electron, that is spin quantum number. Now, if we are talking about the nucleus, in the similar way, nucleus also rotate around its axis. And the angular momentum of nucleus can be given by the expression under root I plus 1 h upon 2 pi, and h upon 2 pi can also be written as h cut h cross. Whatever you want to say, you can say. Where I is spin quantum number for the nucleus. Now, what is the difference between the spin quantum number for the nucleus and for the electron? We know that for the electron, the value of spin quantum number is fixed, either plus half or minus half. But nucleus have different composition. The nature of nucleus depend upon the nature of atom. So the value of spin quantum number for nucleus is not same. Correct? Now, when nucleus moves around its axis or revolve around its axis, it generates a magnetic field like electron do. इलेक्ट्रॉन के बारे में हमने पढ़ा होता है स्ट्रक्चर ऑफ एटम में, दैट्स व्हाई मैं वहां पे कंपैरिजन करता हुआ चल रहा हूं. So basically moving nuclei generate a magnetic field. Hence we can say that nuclei behave like a tiny magnet. Now for a motion of a positive charge, let's apply the right hand thumb rule. मैंने आपको इनिशियली बताया था कि मैं कुछ डिस्कस करूंगा, कुछ फंडामेंटल थिंग्स को बताऊंगा, इसलिए मैं इन चीजों को डिस्कस कर रहा हूं. सपोज a nucleus revolving around in this direction, that is anti-clockwise direction. Now as per right hand thumb rule, if finger is in the direction of current, then thumb show the north pole. So if finger is point out in the anti-clockwise direction, then the direction of thumb suggests the north pole. So for a nucleus revolving in the anti-clockwise direction, this is the north pole, this is the south pole. Similarly, consider clockwise motion. If you are considering the clockwise motion, this will be the north, this will be the south. Correct? This is the case of a positive charge moving and producing or generating the magnetic field. Now, अगर आप इलेक्ट्रॉन की बात करते हो, then direction will be reverse. Now suppose we know that orbital contain two electrons of opposite spin. Why so? Now here I am talking about the spin of negative charge electron. As I told you, right hand thumb rule reverse कर देते हैं. If electrons are revolving in the anti-clockwise direction, this will be the south, this will be the north. And in case of clockwise direction, this is the south, this is the north. So these two electrons, opposite poles, are attract to each other. So these two electrons basically create a magnetic field which attract to each other. Similarly in case of nucleus. Correct? So basically when nuclei revolve or rotate, it behaves like a magnet, hence generate a magnetic field whose direction can be identified on the basis of right hand thumb rule. Now let's talk about the principle of NMR, how it works. So basically any nuclei in the absence of magnetic field can rotate in any possible direction. Correct? But if we applied the magnetic field, they align themselves in such a way so that they can decrease its overall energy. Hence, they will align themselves in the direction of magnetic field. This is the concept of magnetism. Now, in the diagram, you can see the diagram. A free nucleus is placed between the north and south pole of a magnetic field. Now we applied the magnetic field H naught. Now you can see that nucleus align itself in such a way that they feel more attraction, or you can say that they feel more less energy or less potential energy. So when you apply the magnetic field, nucleus align themselves in the direction of magnetic field. Now, if you see the full form of NMR, it suggests it is the nuclear magnetic resonance. Now we put the nucleus in the magnetic field, and to decrease its overall energy, nucleus align themselves in the direction of magnetic field. अब आपको समझ आया होगा कि मैंने क्यों नॉर्थ और साउथ पोल का डायरेक्शन आपको बताया। न्यूक्लियस ने अपने आप को ऐसे अलाइन किया कि मैग्नेटिक फील्ड के साउथ पोल की तरफ न्यूक्लियस का नॉर्थ पोल रहे और नॉर्थ पोल की तरफ साउथ पोल रहे। नाउ हाउ NMR works, how we can detect functional groups, different protons in the magnetic field. Let's talk about that. This is the basic fundamental diagram of NMR. We applied a magnetic field H0. Nucleus aligned themselves in the direction of magnetic field. Now, we must know that magnetic nuclei absorb in the radio frequency region. So we apply the radio frequency region so that nucleus can absorb in this region, or at the bottom of the, or you can say in this direction, we put the detector. Now what is the meaning of resonance here? You give the radio frequency to this nucleus. Now if this energy is sufficient to flip the direction of alignment of nucleus, मीन्स अगर न्यूक्लियस ने इतना एनर्जी एब्जॉर्ब किया कि वो अपने आप को एंटी पैरेलल टू द मैग्नेटिक फील्ड कर सकता है, और इट कैन एबल टू फ्लिप against the direction of magnetic field, then this phenomena is called magnetic resonance. So suppose nucleus absorbs some energy which is not sufficient to flip the direction of tiny magnet or nucleus, then it will transmit the energy which is detected by the detector. Now you are passing the energy which is lower than the energy required to flip. It keep on passing to the detector. Once the sufficient amount of energy is absorbed by the nucleus, it will flip itself in the direction opposite to the magnetic field. Now here comes the resonance. This absorbed frequency is actually give you the idea. Now, this is a small graph which suggests this is the barycenter for the free hydrogen atom. Now, in the magnetic field, nucleus align themselves at the lower energy state, that is in the direction of magnetic field, while if they absorb energy sufficient to flip the direction of magnetic nuclei, or that is the direction opposite to the applied field, This is the energy which they absorb. इसका मतलब है कि रेडियो फ्रीक्वेंसी रीजन में एटम और यू कैन से दैट न्यूक्लियस अपने आप को अपोजिट डायरेक्शन में अलाइन कर लेंगे. अब in which frequency region they will absorb, that depends upon the nature of nucleus. So different nucleus required different amount of energy to flip. And it is also possible that not all the nucleus absorb in this region. So you can say they never flip, so they are NMR inactive. Correct? So if nucleus get that amount of energy so that he can oppose H naught and reverse its direction, so we can say that it is the magnetic resonance. Correct? Now कौन से न्यूक्लियस एब्जॉर्ब करेंगे, कौन से नहीं करेंगे? Let's talk about the criteria of NMR active and NMR inactive nuclei. Now, this table suggests you or give you an idea about the NMR active or inactive nuclei. Suppose if there are even number of protons and even number of neutrons are present inside the nucleus, in that case, nucleus is NMR inactive. Why? Because if they are in even number, they will cancel out their magnetic moment. Okay, here you get the reason also. अब एक चीज और, one more thing came into my mind, or as a learner you also think, some protons are charged species. They can behave like a tiny magnet. But why we include neutrons here? Why not be just the NMR active or inactive nuclei on the basis of protons only? Why we include neutrons? Neutrons are the neutral species in the structure of atom. We heard about that. So let me talk about some specific point. There are some subdivisions of proton and neutrons. Those subdivisions are called quarks. They are of 6 types. Up, down, top, bottom, strange and charm. Correct? So, if you see the case of proton, there are 2 ups and 1 down quark. And the charge on up is 2 by 3, while on down is minus 1 by 3. If you calculate the total charge of each quark, you will get plus 1. While in case of neutron, if you see the neutron, this is for proton. But for neutron, if you see the neutron, there are 2 down quark and 1 up quark. Here the total charge is 0. So basically neutron have some charge area, or you can say subparticles, subregions. Overall charge will be 0. So they also support the nucleus to behave like a magnet. That's why nucleus must have some net magnetic moment due to proton as well as due to neutrons. Now एक बात यहाँ पर डिस्कस कर लेते हैं पहले. Total number of possible orientation in the magnetic field for a nucleus is given by 2i plus 1. Generally, electrons के केस में हम कहते हैं spin multiplicity. So here we know we can say that they are the possible orientation. That they are 2i plus 1. Where the value of i is equal to n by 2. N can have any value 1, 2, 3. So the value of I can be 1 by 2, 1, 3 by 2, 2, 5 by 2, etc. Now those have fraction values are known as fermions. Those have integer value are known as bosons. Correct? So even protons, even neutrons, such nuclei are NMR inactive because the I value for them is 0 or they have 0 orientation or they will not orient. Such nuclei, if you see the examples, such nuclei are oxygen and carbon. Now, if one of them, either proton, either neutron, if they are in the odd number, you will get the fractional value of I. If you have protons even, neutrons odd, or if you have odd protons or even neutrons, you will have fractional I value. Correct? Now, if you take some example of these, like hydrogen nuclei, fluorine nuclei, phosphorus nuclei, they have I is equal to 1 by 2. If you have boron nuclei, if you have chlorine nuclei, I think bromine also, yes, bromine also, they have 3 by 2 value. Copper also have 3 by 2 value. Titanium also have 3 by 2 value. 13 carbon. We can find out the protons and neutrons and then predict the I value. Iodine have 3 by 2 value. Isotope of oxygen, which is NMR active, is 17, have 5 by 2 value of I. Correct? If both are odd in nature, then they must have integer I value. Like you have deuterium, you have nitrogen, they have I value is 1. These are the NMR active nuclei. Now, these are the possible orientation for a free nuclei in the magnetic field. If the value of I is 1, there is only one possible orientation, which is perpendicular to the magnetic field. While in case of I value half, there are two possible orientation. One is in the direction of magnetic field, one is in the opposite direction of magnetic field. By graph, you can show that this is the energy, this is the two orientation value, say plus half or minus half. Now for the I value 3 by 2, you have four possible orientation. One is in the direction of magnetic field, one is in the opposite direction of magnetic field, and two in between them. So before getting into the opposite direction, before getting into the flip, nucleus will move into the 2 orientation. समझ आ रहा ना आपको? मीन्स अगर I वैल्यू 3/2 है तो न्यूक्लियस रेडियो फ्रिक्वेंसी रीजन में एब्जॉर्ब करेगा तो पहले 2 पॉसिबल ओरिएंटेशन रखेगा, उसके बाद और it will move in opposite direction to the magnetic field. Now if I value is 1, there are 3 possible orientation. For 2 there are 5 possible orientation. इसका मैंने एनर्जी स्टेज दिखाया हुआ है, -2, -1, 0, +1 और +2. 0 means that is perpendicular to the magnetic field. इसको बहुत ज्यादा डिस्कस नहीं कर रहा हूं, नोट्स में मैंने डाल दिया, you can go through it. Now important thing, every time nucleus is not free, it is surrounded by electron. So definitely due to those surrounding electron, magnetic resonance get affected. And how it get affected, it can be discussed under the topic shielding and de-shielding effect. Till now we discuss about a free nuclei. Now we know that electrons revolve around the nucleus, so they also generate the magnetic field. Generally, the magnetic field generated by electron have tendency to oppose the applied magnetic field. So what happened? This is the magnetic field generated by nucleus. Now electron generate their magnetic field so that they can oppose the applied magnetic field. Correct? Now what happened when you apply the radio frequency waves on the nucleus? They required less frequency to flip because the applied field is opposed by the electron clouds. Hence, nucleus feels less impact of applied magnetic field. मींस इलेक्ट्रॉन ने जो फील्ड जनरेट किया है वो अप्लाइड मैग्नेटिक फील्ड को अपोज कर रहा है. In that case, nucleus is feel shielded from the applied magnetic field. So it required less frequency, less energy to flip. Hence, it can absorb less energy to resonate. So nucleus is said to be shielded. But if magnetic field generated by the electron is in the direction of magnetic field, then nucleus feel more magnetic field. Hence, it required more energy to flip. Correct? In that case, we can say that nucleus is de-shielded. And it requires more frequency to resonate. Now, what happened when you apply the magnetic field? You can say that when you apply the magnetic field, जो nucleus feel करता है magnetic field, that will decrease. So net magnetic field operated on the nucleus is actually the applied field minus induced field. Induced field is due to the electron. Now more the applied field, more will be the induced field. जितना इलेक्ट्रॉन मैग्नेटिक फील्ड जनरेट करेगा उतना ही ज्यादा मैग्नेटिक फील्ड हमें अप्लाई करनी पड़ेगी अगर वो एक दूसरे के डायरेक्शन को अपोज कर रहे हैं. मीन्स इलेक्ट्रॉन ने रिवॉल्व किया, इलेक्ट्रॉन में मैग्नेटिक फील्ड जनरेट किया. क्यों जनरेट किया? टू अपोज द अप्लाइड मैग्नेटिक फील्ड. सो इफ यू अप्लाई more magnetic field, induced field will be more. Hence, induced field and applied field are proportional to each other. And they're separated by a constant sigma, which is called as shielding constant. So, sigma is actually the ratio of induced field to the applied field. Correct? So, basically, the magnetic field experienced by the nucleus can be given by H applied 1 minus sigma. This is the actual field experienced by the nucleus. So we can say that more shielded the electron, beg your pardon, more shielded the nucleus, it required less frequency, or it will resonate at less frequency. More deshielded the electron, it will resonate at high frequency. Correct? अभी मैं फ्रीक्वेंसी के बारे में बात कर रहा हूं, केमिकल शिफ्ट के बारे में बात नहीं कर रहा हूं. तो फ्रीक्वेंसी की टर्म में आपको समझिए, ये केवल आपको शील्डिंग और डीशील्डिंग समझाने का प्रयास किया गया है. आपने से पहले से पढ़ा होगा, तो आप कंफ्यूज ना होइएगा. मैं आपकी बात पर आ जाऊंगा, डाउन फील्ड शिफ्ट और अप फील्ड शिफ्ट पर आ जाऊंगा. मैं अभी फ्रीक्वेंसी की बात कर रहा हूं. If the nucleus is more shielded, it will resonate at less frequency. While if nucleus is deshielded, it will resonate at high frequency. Correct? हमने यहाँ पे एग्जाम्पल लिया है ब्रोमोइथेन का. If you see the example of bromoethane, now there are two types of hydrogen nucleus. They are designated as A and B. Now if you see the Br is more electronegative than carbon, and apply the minus I effect on the carbon chain. So the atom B feel deshielded as the sigma electrons are moved away from the carbon, they move towards the bromine. So B is more deshielded in comparison to A. A is shielded. So if you draw the graph of intensity versus frequency, you find that A absorb at low frequency region, while B absorb at high frequency region. Although हमें mention कर दिया है, low frequency means up field and high frequency means down field. What does it mean? मैं आगे बता दूंगा. मोस्टली स्टूडेंट को यहाँ पर कंफ्यूजन होता है, इसलिए मैंने यहाँ पर अप फील्ड और डाउन फील्ड पहले से ही मेंशन कर दिया है. क्या होता है मैं बाद में बताऊंगा. सिमिलरली मैंने दो और एग्जांपल लिए हैं. देयर आर 3 न्यूक्लियस A, B and C. If you see the nucleus C, there are 2 atoms Br and O which are more electronegative and electron withdrawing in nature. While in case of B, there is only oxygen which is electron withdrawing in nature. So she is more deshielded. If you discuss the deshielded nucleus, you will find C is more deshielded than B and A is shielded. So A resonate at lower frequency. This is the lower frequency region and this is the higher frequency region. Similarly, case of ethanol is discussed here. So basically, if there are more electrons around the nucleus and they oppose the applied magnetic field, nucleus will resonate at less frequency. If nucleus is deshielded or electrons or magnetic field generated by the electrons is in the direction of applied magnetic field, then nucleus experience more magnetic field, hence it require more frequency or energy to resonate. Okay, Now, if we compare the free nuclei and a nuclei surrounded with electron, they will resonate at different frequency. So there is a difference in the resonating frequencies. That difference is measured in terms of chemical shift. Now we need a standard, we need a reference from which we can compare the difference in their resonating frequencies. So TMS is used, tetramethylsilane is used as a reference from which we can compare the shift in frequency. TMS कितनी frequency पर resonate कर रहा है और हमारा जो एटम है वो कितनी frequency पे resonate कर रहा है, उन दोनों का difference क्या कहलाता है? chemical shift कहलाता है. फ्री न्यूक्लियस से कंपेयर नहीं किया गया, टीएमएस से किया गया, रेफरेंस के तौर पर लिया गया. क्यों लिया गया उसके बारे में बात करेंगे. सो बेसिकली केमिकल शिफ्ट क्या है, जिसको हम जनरली डेल्टा वैल्यू से रिप्रेजेंट करते हैं, एंड इट इज गिवन इन टर्म्स ऑफ पीपीएम. करेक्ट. तो शिफ्ट इन पोजीशन ऑफ एनएमआर एब्जॉर्प्शन frequency, you can say that, which arise due to shielding or de-shielding of protons by magnetic field of electrons. In comparison to the standard reference like TMS is called chemical shift. Formula for the calculation of chemical shift is given by this expression. We suggest it is the frequency of sample at which sample is resonate. It is the frequency of reference, that is TMS, divided by operating frequency in megahertz or megacycle per second into 10 to the power 6. This factor is introduced to overcome the megahertz term. Correct? मैंने साथ में एक बुक का रेफरेंस भी लगाया हुआ है जहां से आप केमिकल शिफ्ट को समझ सकते हो. करेक्ट है. अब इसके बाद की जितनी बातें होंगी वो सारी रेफरेंस के साथ होंगी, बुक्स के रेफरेंस के साथ होंगी, जिससे कि आप ज्यादा बेटर वे में समझ पाओ. Now, why we use TMS as a standard? कोई भी ऐसी चीज जनरली जिसमें सारे ऑर्गेनिक कंपाउंड सॉल्युबल होंगे उनको रेफरेंस के तौर पर लेना इजी होता है. सो TMS is miscible with all the organic substances, as well as it is highly volatile in nature, having less boiling point, so we can remove it from the sample easily, and it does not participate in the chemical association or dissociation. As well as most important thing is it resonates at very high field. Most of the organic protons resonate at a lower field than the proton of TMS. Correct? You understand the meaning of lower field here? अभी मैंने पूरा डिस्कस नहीं किया, बट ग्राफ में बताया था. लो फ्रीक्वेंसी अप फील्ड, हाई फ्रीक्वेंसी डाउन फील्ड. Means most of the organic compound resonate at lower field, that is higher frequency, than the proton of TMS. Now, back to that point, if it resonates at lower frequency, you will get a field in comparison to the TMS. That means shielded nuclei resonate at lower frequency, and in comparison to TMS, they are at a field. यहां पर मैंने समझा दिया आपको. Deshielded nucleus means downfield shift from TMS, hence higher delta value. डिफरेंस ज्यादा हो जाएगा ना TMS के कंपैरिजन में. इस ग्राफ को देख लेंगे, समझ लेंगे. ड्यूरिंग राइटिंग द आंसर ये ग्राफ यूज कर सकते हैं. अगर हमें असाइनिंग द डेल्टा वैल्यू दिया गया है तो हम इस ग्राफ से समझा सकते हैं डायग्रामेटिकली किसको हम अपफील्ड कह रहे हैं, किसको हम डाउनफील्ड कह रहे हैं. So TMS assigning the zero value, you can see that. So highly shielded nuclei is in the upfield, that is they will resonate at lower frequency, close to TMS, while deshielded nuclei absorb downfield. Now there is one more scale, tau scale. We can also measure the tau scale values to show the upfield and downfield. This is how we can find out the tau values. यहाँ पर sum up किया गया है. If the protons are in the electronic poor environment, they are deshielded protons, downfield, absorb at high frequency and large delta values. Correct? Protons in electron dense environment, they are shielded protons, upfield, resonate at lower frequency, having small delta value. अब यहां से एक इंपॉर्टेंट लाइन है जो आप याद रख सकते हैं. ग्रेटर द वैल्यू ऑफ केमिकल शिफ्ट, हायर द फ्रीक्वेंसी. कौन सी फ्रीक्वेंसी? रेजोनेट फ्रीक्वेंसी. तो मैंने कहा था कि मैंने कुछ बुक का रेफरेंस भी लिया हुआ है दैट विल हेल्प यू टू सॉर्ट आउट द प्रॉब्लम्स रिलेटेड टू द NMR. नाउ लेट्स डिस्कस अबाउट सम न्यूमेरिकल प्रॉब्लम्स. काफी सारी न्यूमेरिकल प्रॉब्लम्स दी हुई हैं, कुछ PYQs हैं और कुछ रेफरेंस बुक से कंसीडर किया गया है. एक वाला सवाल देखते हैं हम. 10 मार्क्स का क्वेश्चन है ये. कैलकुलेट द केमिकल शिफ्ट इन ppm फॉर अ प्रोटॉन दैट resonate it should be resonate at 126 hertz downfield from TMS on spectrophotometer that operates at 60 megahertz. Up, although I'm not taking LAW classes here, we are not discussing about the writing things in this lecture, but still मैं आपको बता दूं, although it is a 10 marks question, but you can define chemical shift. क्वेश्चन राइट करते वक्त तीन चीजें होती हैं: इंट्रोडक्टरी पार्ट, मेन बॉडी एंड कंक्लूजन. ओके, केमिकल शिफ्ट यू कैन डिफाइन इन वन लाइन. एंड व्हाट इज द मीनिंग ऑफ डाउनफील्ड फ्रॉम TMS? You define. These two things can be added during your answer writing procedure to make your answer, look like better than other. Okay, otherwise numerical is too short. It's a only one step process. Now you know the formula. Delta n ppm is new sample, new reference operating frequency into 10 to the power 6. Now sample absorb at 126 hertz while operating is 60 into 10 to the power 6 megahertz में था, hertz में convert कर लिया. It is approx 2.1 ppm. अब रिजल्ट लिखना है तो डाउनफील्ड शिफ्ट है 2.1 वैल्यू CH2 मिथाइलिन प्रोटॉन का आता है अप्रोक्स. तो आप बता सकते हो कि इट सीम्स लाइक अ मिथाइलिन प्रोटॉन. हालांकि किस फंक्शनल ग्रुप का क्या वैल्यू होता है वो हम आगे डिस्कस करने वाले हैं. Let's discuss some more problem. ये भी 10 मार्क्स में है. A signal has been reported to occur at 120 Hz downfield from TMS in an NMR spectroscopy. Almost same about 126 था या 120 है. What is chemical shift? So delta will be 120 into 10 to the power 6 upon 60 into, so it should be 2 ppm. Correct? This is the first part. Second part, what would its chemical shift be in an instrument operating at 100 megahertz? So it's too easy to handle this problem. बार बार एक ही चीज को पूछा गया है. It's like a bonus problem to all. Third, how many hertz downfield from TMS would the signal be in 100 megahertz spectrometer? Okay. So suppose shift from TMS is X and operating frequency is 100. And the value of chemical shift is 1.2 in case of 100 megahertz. If you are taking the value in delta and ppm, then you should write operating frequency is megahertz. So X is equal to 120 hertz. Because this is in the ppm, 10 to the power minus 6, and this is 10 to the power 6. So 120 hertz. Correct? These are the similar type of problem. You can solve. If you want answer, let me write the answer so that you can verify them. For question number 7, 600,000 2 ppm 2 ppm 1000 downfield. For 9, 1.5 ppm and 150 hertz is the answer. Correct? If you have any sort of doubt in solving these problems, you can ask. Now there is one more problem. चलो उसको मैं solve कर देता हूँ. Dichloromethane has a chemical shift of 532 hertz. I think it is also a P by Q from TMS on a 100 megahertz spectrometer. What will be the chemical shift in ppm? So it's again quite simple. .32 ppm. Next part, what would be the chemical shift B in ppm and hertz on a 600 megahertz spectrometer? What would be the chemical shift in ppm okay. Suppose the shift is X, operating frequency is 600, then you will get X is equal to 5.32 into 600, 6 2s are 12, hertz. Correct? This is how you can find out the value of delta by using the formula. Now there are some questions which are asked. Number of NMR signal. Number of NMR signal depends upon the type of, हम यहाँ पे HNMR की बात कर रहे हैं ना, type of hydrogen atom present in the molecule. Okay, मैं बहुत ज़्यादा फंडामेंटल से नहीं ले रहा हूँ, बेसिक चीज बता रहा हूँ. Now you can see that there are three types of hydrogen, A, B and C. They are present in different environment. Like there are two CH2 group, but CH2C is attached with bromine, so it will resonate at different delta value in comparison to B. अभी मैंने आपको शील्डिंग बताया था, bromine is electron withdrawing, so she will be absorb or resonate at more frequency, hence downfield in comparison to B. आप I और F का ग्राफ भी बना सकते हैं इनका. So there are three types of signal. Okay, I'm taking few examples, not all. Now if you see this, further there are three types of protons. CS3 and CS3 are different because this CS3 is more deshielded. It is attached to oxygen. So both CS3 resonate at different frequencies in comparison to C. If you need to consider which is downfield, which is upfield, so B being less shielded resonate at high frequency and hence downfield. A is more shielded, resonate at low frequency. Now these 2 CS3 are equivalent magnetically equivalent nuclei. Both are attached with oxygen in a similar way, so we'll get a single signal. Now if you see A and B, both are resonate at different frequencies, so they will produce two signals. As I already told you, more shielded resonate at less frequency. Less frequency means upfield. So if you see the B, it is attached with two chlorine electron withdrawing in nature, oxygen. So B is more de-shielded. Now if you see these two protons, they are magnetically equivalent. You can see their surrounding atom. वैसे तो we should discuss about the enantiotopic and distereotopic hydrogen. बट अभी उसको डिस्कस नहीं करते हैं, टॉपिक थोड़ा सा अलग हो जाएगा. Now let's move further. These two are magnetically same nuclei, hence produce one signal. मैं एक बात कहना चाह रहा था, इसलिए मैं सोच रहा था कि बताऊं या नहीं बताऊं. एल्कीन्स में जो प्रोटॉन्स नॉन मैग्नेटिक न्यूक्लियाई होते हैं, नॉन मैग्नेटिक नहीं बोलेंगे, मैग्नेटिकली सेम ना हो, अगर मैं उनके बारे में बात करूं तो वो डाइस्टेरियोटॉपिक होते हैं. और डाइस्टेरियोटॉपिक जो प्रोटॉन्स होते हैं वो डिफरेंट फ्रीक्वेंसी पर रेजोनेट करते हैं. ऐसा एक एग्जांपल आगे आएगा तो मैं आपको बता दूंगा. इन बेंजीन ऑल द न्यूक्लियाइज आर मैग्नेटिकली इक्विवेलेंट, सेम. Now NO2 group is attached. Now if you see these two nucleus, both are in same chemical environment, so they are magnetically equivalent. Similarly, these two are same, but this is in the different environment. So there are total 3 signals, while in case of benzene there is only one signal. Now let's talk about ethyl benzene. Ethyl benzene, I think P by Q है. Now you can see these two are different nuclei. These two are different. These two are different, and this is also different. So there are total 5 NMR signals. For mesitylene, these are identical nuclei, or they are in same chemical environment, so they are magnetically same nuclei. These are also same but different from the A. So there are two NMR signals. These two CH2 protons are in same environment, while CH3 are in same environment but different from the CH3. So you will get two signals. For propanol, there are three different type of proton. You will get three NMR signal. So here different examples are given to you. You can practice yourself. जो मैं आपसे बात कर रहा था डाइस्टीरियोटॉपिक वाली. So stereochemistry में hope you discuss about the enantiotopic and distereotopic. So you can see the HA and HB. They are distereotopic proton, so they resonate at different frequency. और अगर सिंपल वे में कहें, अगर यहाँ पर देखें HA का एनवायरनमेंट में एक प्रोटॉन है, HB के एनवायरनमेंट में ब्रोमीन है, so they are in different environment. But technically they are distereotopic in nature. They are not reflected by a plane. सिग्मा भी पास नहीं हो रहा इसके अंदर से. खैर स्पेक्ट्रोस्कोप हम अभी ग्रुप थ्योरी पर नहीं जाते हैं. H and HB are distereotopic in nature and they are non-equivalent, so they resonate at different frequency. So there are total 3 NMR signal. Similarly, if you see chlorine attached to this carbon, so this carbon and this carbon is magnetically same, so these two protons are magnetically HC and HC are magnetically same, but not HD and HT, because you can see that chlorine is present in their environment, while for these two HC there are another proton which is present in their environment. Again यहाँ पर भी हम enantiotopic और distereotopic का concept apply करेंगे तो ज़्यादा समझ में आएगा. They are not reflected by a mirror, but they are attached to the center which contain two different group. And if you give the 1-1 substitution, ये भी chiral हो जाएगा, ये भी chiral हो जाएगा. So यहाँ पर थोड़ा सा अगर आप distereotopic और enantiotopic का concept apply करेंगे, you will give a better answer. That's why there are total 5 NMR signals. नेक्स्ट लेक्चर में मैं उसको कवर कर लूंगा. अभी मैं कट शॉर्ट करने वाला हूं. यहाँ पर एक असाइनमेंट दिया गया है, उसके आंसर्स भी नीचे मेंशन है, आप इसको करिए. अब आते हैं हम समरी चार्ट पर. यहाँ पर कुछ फंक्शनल ग्रुप और उनका डेल्टा वैल्यू का जो रीजन है वो मेंशन किया गया है. डिफरेंट सोर्सेज से मैंने लिया गया है. करेक्ट. यहां पर मैं देखता हूं आपके लिए एक मोस्ट कॉमन वाई शर्मा का डायग्राम है. ये आप स्पेक्ट्रोस्कोपी के लिए, ऑर्गेनिक स्पेक्ट्रोस्कोपी के लिए अगर फंडामेंटल कोई किताब चाहिए जो आसानी से आपको समझा दे, वो वाई शर्मा है. सिल्वरस्टीन का बुक देख सकते हैं स्टैंडर्ड रेफरेंस के लिए. पाबिया का काफी अच्छा बुक है, वहां से आप देख सकते हैं. और जगदम्बा का बुक प्रॉब्लम से रिलेट करता है, तो प्रॉब्लम्स के लिए अच्छा है. नाउ एल्डिहाइडिक प्रोटॉन्स जो होते हैं उनका डेल्टा वैल्यू 9 to 10 के बीच में आता है. मीन्स दे एब्जॉर्ब डाउनफील्ड. एरोमेटिक रीजन्स, कैरेक्टरिस्टिक रीजन है 6 to 9 के बीच में रहता है. ऑलिफिनिक रीजन अप्रोक्सीमेट 7.5 से 4, मोर देन 4 के अराउंड रहता है. और ये वाला जो रीजन है इसमें मोस्टली CH2 प्रोटॉन्स रेजोनेट करते हैं. डिपेंड्स अपॉन देयर नेचर. इलेक्ट्रॉन विड्रॉइंग ग्रुप ज्यादा अटैच्ड होंगे, तब ज्यादा डेल्टा वैल्यू आ जाएगा. तो अगर मैं बात करूं असाइनिंग द डेल्टा वैल्यूज के बारे में, इस लेक्चर में बात करते हैं। थोड़ा फास्ट इसलिए लिया है मैंने क्योंकि मुझे पता है कि आपने ये शायद पढ़ा हुआ है और मेरे को इंपॉर्टेंट पॉइंट्स डिस्कस करने हैं। सो इफ यू सी द इलेक्ट्रोनेगेटिविटी ऑफ एटम, delta value is directly proportional to electronegativity of atom, because electronegative atom cause minus I effect, hence it cause de-shielding effect, and de-shielding effect shift the frequency at higher and downfield. Downfield in comparison to TMS. Now if you see the example, सिंपल सा एग्जाम्पल है, CH3F, CH3Cl, CH3Br. If you see, the electronegativity is decreasing. So basically electronegativity is decreasing, that means delta value should be decreasing. So the value of CH3F is approx 4.25. I am taking this data from different sources. No need to learn the value. This will just suggest you the impact of electronegativity on the delta value. Correct? Hydrogen bonding also impact the delta value. Hydrogen bonding atom compatibly absorb at lower field in comparison to the one which does not involve in the hydrogen bonding, because hydrogen bonded atom, in case of hydrogen bonded proton, hydrogen atom is attached to highly electronegative atom. So electron density become less and hence it feel de-shielded. De-shielded means it will resonate at high frequency or downfield. So if you see the example, this is the enol form. If you count the signal, A, this is B, this is C, this is D. Now if you assign the delta value, you should know that A and D is actually methyl group which absorb in the delta value near 1 to 4. So if you assign the value of A and D, you will find that the approximate value of A is near about 2. While in case of T, the approximate value is 5.5, say 5. Why this difference? It is due to the CO group, minus I effect of CO group. Now let's talk about the C. C is olefin. I did a mistake here. Basic the D value इतना difference नहीं आएगा. D value is also close to 2. .2 approx. Well, if you see the C value came into the region of 5.5 delta. So I told you in the chart, this is the olefinic region. So it is olefinic as well as impacted by minus I. So it is more towards de-shielded and downfield. अगर माइनस आई इम्पैक्ट नहीं लगता तो ये 4.5 अप्रॉक्स हो सकता था. You see the value of B is hydrogen atom attached to hydrogen bonded oxygen atom. So as discussed, approximate 12 or more than 12 delta value. See the impact. It's the enol form. अगर इसका कीटो फॉर्म बनाया तो इट्स कीटोनिक, तो 9 to 10 के बीच में इसका होना चाहिए था, बट ड्यू टू हाइड्रोजन बॉन्डिंग it become more de-shielded and more downfield. The value of approx 12 delta. ये वैल्यू अप्रोक्सीमेट है, मुझे भी एग्जैक्ट याद नहीं है, जरूरत भी नहीं है. Hope you understand what I am saying. Now let's take some more examples so that we can assign the delta value and understand in a better way. Suppose we are given this molecule. So first of all, we need to assign the total number of signal. So these two methyl groups are in same environment, while this B is in the different environment. Now if you see the CN applying the electron withdrawing effect. So if you compare the delta value of B and A, you know B is more de-shielded in comparison to A. So B become more downfield. So we have more delta value in comparison to A. रीजन क्या रहेगा? CH का रीजन क्या होगा? अप्रॉक्स 2.6, 2.7, 2.8. और CH3 का क्या रहेगा? लेस देन 2. मिथाइल जनरली क्या होते हैं? लेस देन 2 पे रहते हैं. डेल्टा रेंज 1 to 2. While CH2 अगर है तो it is more than 2. Depend upon the nature of electron withdrawing group. Now take another example. Okay, if you need to count the number of NMR signal, there are two types of NMR signal. B is more de-shielded in comparison to A. Again, the similar result will obtain. ये थोड़ा अच्छा प्रॉब्लम है, लेट्स डिस्कस इट. यहाँ पर 3 सिग्नल मिलने वाले हैं, A, B एंड C. Now what are the different values? किसका डेल्टा वैल्यू सबसे ज्यादा होने वाला है? CuNH का. फंक्शनल ग्रुप रीजन 9 to 10 के आसपास बताया था मैंने आपको. बट CuNH का अगर हम देखेंगे, फंक्शनल ग्रुप रीजन यहां पर हमें मेंशन होगा CONH. This is CuNH. 2.5 ppm means approx 7.5, 7.8. टाउ वैल्यूज थी ना वो. तो अगर हम अब देखते हैं CuNH का, या स्टार्टिंग फ्रॉम CH3. CH3 का रीजन क्या होगा? डेल्टा वैल्यू अप्रॉक्स 2 होगा. इफ यू टॉक अबाउट C, माइनस आई इफेक्ट ऑफ NH कॉज मोर डाउनफील्ड, मोर डीशील्डिंग. So value of C is slightly high, more than 2, 2.3, 2.4. The value of B, so value of B approximately 8, near about 8. Let's take another example of butane 2-one. There are three types of signal, A, B, and C. A is more shielded in comparison to B and C. Now, if you compare the delta value, it would be easy to decide. सबसे कम डेल्टा किसका होगा? ए का होगा. If you see B and C, थोड़ा मुश्किल है, बट बी को अगर देखेंगे तो CH3 का प्लस आई इफेक्ट भी आ रहा है. करेक्ट. Number of signal. There are 4 number of signals. इंटरेस्टिंगली जो ए का वैल्यू होगा वो किधर होगा? 9 to 10 के रीजन में होगा. एल्डिहाइडिक प्रोटॉन है. इफ यू कंपेयर द बी, सी एंड डी वैल्यू ऑन टाउ स्केल, थोड़ा देर टाउ स्केल के बारे में बात कर लेते हैं. इफ टाउ स्केल पर कंपेयर करेंगे बी, सी एंड डी का, डी हैव हाईएस्ट वैल्यू, देन सी, देन बी. एंड बेंजीन रिंग का एक कंसिडर कर लेते हैं. इफ यू कंपेयर द टाउ वैल्यू, बी देन ए, देन सी. And I think this could be the last example. There are 3 signal. A, B and C. If you compare their tau value, that is opposite to delta, you can say that. You see the tau value C, A and B. मेरा मन नहीं भरा, एक एग्जांपल और ले लेता हूं. अब डेल्टा वैल्यू के बारे में बात कर लेते हैं. बार बार चेंज कर रहा हूं जिससे कि आप अंडरस्टैंडिंग बना पाए. एग्जाम में ए या टाउ या डेल्टा कुछ भी रहेगा, आप एक टर्म याद कर लीजिए, डेल्टा या टाउ, उसके अकॉर्डिंग अपना आंसर चेंज कर सकते हैं. ए, बी एंड सी. नाउ इफ यू सी ए, बी एंड सी, वैल्यू ऑफ सी क्या होगा? इट शुड बी मोर देन डेल्टा, मोर देन 10, सॉरी, मोर देन डेल्टा, मोर देन 10. 9 to 10 एल्डिहाइडिक रहता है, कार्बोक्सिलिक का 10 से ज्यादा ही आएगा. अप्रोक्सीमेट 11 पॉइंट समथिंग होना चाहिए. Now if you compare the A and B, you feel that B is more deshielded in comparison to A. So delta value is near about 2 for A, but for B it should be more than 2. आपके लिए छोटे से 2 एग्जांपल देता हूं. आप प्रिडीन के सिग्नल और उनका वैल्यूज फ्यूरॉन के सिग्नल और उनका वैल्यूज निकालिएगा. And this example should try yourself. Okay, so that's it for the day. Next lecture में मैं आपको बताऊंगा how to write the answer of such problems. We will discuss some previous year questions. We will discuss coupling constant. So we are done with it. Hope you enjoyed the lecture.